Hello. In the previous video, we've been dealing with definite integrals and how to evaluate a number or the value of the definite integral. Today, we are going to talk about the properties of definite integrals. When looking at the properties of definite integral, actually, we can start with the following one. If I'm integrating from a point A to the same point f of x with respect to the x. We all know that, or as I said last time, the definite integral is the area under the thing. So if I did not move from a to a, the integral will be 0. For example, if I have, what is the integration from pi to pi of, sorry, the integration of from pi to pi of sine x dx, because I'm not going anywhere, I'm still at the same point, so the answer will be 0. So this is the first property where I have to find the integral from a point to itself. Now, the second thing, if f of x is an integral from a to b, then we can define the integration from a to b of the function f of x dx to be the opposite of the integral from b to a to the same function. So integration from a to b is negative integration from b to a. For example, if I have the following question, say given sorry, yeah, I have a problem with my pen today, so I'm sorry for all this mess right now. Given the integration from -2 to 3 for a function f of x dx was found to be 21, and my question find the integration from 3 to -2 f of x dx. Nice. As we just said from the previous property, from -2 to 3 the integral is 21, so from 3 to -2, obviously the integral is going to be this one, will be the opposite of that number, which is -21. These are the first two properties for definite integral. Let's continue. So let me label them again. This was number 1, this was number 2. Now, the third one is, assuming that I have 3 points, I'm going to start from A, reach to B, and ends at C. If I want to calculate the area from A to C, it is the same as the area from A to B plus the area from B to C. How do we write this one as integral? Easily. The third property of definite integral is the integration from A to C f of x dx equals to the integral from A to B for the function plus the integral from B to C f of x dx. It looks like يعني B هي واسطة عشان توصلني من A ل C. فده total integral from A to C هو من A to B وبعدين بكمل نفس الفاليو from B to C. Uh, why do we use this? Because in many times if we are talking about functions just like say the absolute value. Okay, say I'm gonna talk about the absolute value function, which is somehow like this. Assume that I want to find the integration from -1 to 1 to the function absolute value of x dx. Looking at this one, uh, as we said last time, the integral is the area. So in this case, from -1 to 1, I'm talking about this area and this area over here. But since I want to find the integral from -1 to 1, if I found it directly, it's going to be 0 because the negative will either positive. So what I'm going to do is I'm going to assume that this one equals the integration from -1 to 0 plus from 0 to 1. We all know that absolute value of x, it has actually two rules. It is x when it's positive and negative x when it is negative. So from -1 to 0, I'm talking about the negative, that is -x dx, and from 0 to 1, it is positive, so it is x dx. The integral from -1, it's -x squared over 2, which is going to be negative half squared, it is half, plus from 0 to 1, it's going to be another half. So each one of them, this one is a half, this one is half, and the area is 1. So because the absolute value is a special case. Now we talked about three things, and now let me say another example regarding to this one. Let me try to make assume that I said the integration from -1 to 5 f of x dx equals 8. And I told you that the integration from -1 to 3 equals 12. My question is, find the integral from, let me make harder a little bit, 5 to 3 f of x dx. If I have like this question, two integrals, and he is asking me about the third one, I prefer to use my line always. You started from -1, you stopped at the 3, and then you continue to the 5. You tell me that from -1 to 3, the integral is 12. From 3 to 5, the integral is, I wish I know, and from -1 to 5, the whole integral is 8. This one is 12. So the integration from 3 to 5 is the bigger one minus the smaller one, because if you add this one plus this one, it's going to be 8. So 8 equals 12 plus, let me say, x. Am I right? So x equals 8 minus 12, which is negative 4. X in this case is the integration from 3 to 5 f of x dx equals negative 4. But I'm not asking in this one. My question is asking me to find the integral from 5 to 3. Back to the second property, then the integral from 5 to 3 to f of x dx equals, if this one is negative 4, that one must be a positive 4. And yes, I'm talking about the second property in this case. Here are some properties of definite integral, and we will continue with the coming worksheet. I will distribute a worksheet for you to try to deal with it. Thank you very much. Uh, by this, what we have to do for the whole week is just solving more questions and more problems on definite integrals. Thank you.